Daily work unit 3-4. It says name the triangle 3 ways. We could actually name the triangle 6 ways. You can start at any vertex and either go clockwise or go counterclockwise and name the triangle. So one way is to say triangle HIF, and you can name it 2 more ways. Again, there's 6 possibilities. Again, a triangle is a figure formed by 3 segments joining 3 non-collinear points. The 3 segments are called the sides. So the sides of a triangle are segments. The vertices are the 3 non-collinear points. So the vertices are point H, etc. The sides are the 3 segments that joined those 3 non-collinear points, which are segment HF, etc. Okay. We're going to name these triangles according to the lengths of their sides and the angle measures of their angles. The lengths of their sides and the measures of their angles, and there may be more than one name for each. So according to the lengths of the sides, this one has no equal sides, and the name for no equal sides is scalene. It also has one angle that's more than 90 degrees, and the fact that it has one angle more than 90 gives it the name obtuse. Number 5 has 2 different names. Number 6, we could give 4 different names. And we'll let you think about those 4 different names. Okay? Number 7, angle 2 plus angle 4. Well, from the corollary, we know that these are the acute angles of a right triangle. One of the corollaries from the Theorem 311, which says the sum of the angles of a triangle is 180, tells us that the acute angles of a right triangle are complementary, and we know that complementary angles are 2 angles whose measures have the sum of 90 degrees. So we conclude there that angle 2 plus angle 4 is equal to 90 degrees. If angle 6 is 137 degrees, then what can we conclude about angle 4? Well, when you put angle 4 and 6 together, you see that angle 4 and 6 are a linear pair. That tells us that angle 4 plus angle 6 is 180 degrees. So if we subtract angle 6, which is 137 degrees, from 180 degrees, we will get angle 4, which is 43 degrees. So angle 4 must be 43 degrees. Since angle 2 plus angle 4 is 90, then we should be able to take 90 minus angle 4, which is 43 degrees, and get angle 2, which is 47 degrees. Any questions on number 9? Let's go to number 11. Number 11 is with the bottom picture. If you wasn't sure when it changed, it's when the letters changed. We got the ARF here, and that's the letters in this. So here we are at the bottom picture. Angle 2 plus angle RQB. Now here's angle 2. angle RQB goes from R2Q to B. You put them together and you have a linear pair, right? So angle 2 plus angle RQB is 180 degrees because they're a linear pair. Any questions on that? We have some draw and label accurately, and we would want you to get a ruler and draw these exact. It says isosceles triangle ABC, the equal sides are 7/8 of an inch. The equal sides are 7/8 of an inch. That gives you some leeway, but what you would do is you would make a point, you would get a ruler, and this is going to be blown up a little out of proportion. If this was the 1 inch, and this was the half, and that was the fourth, and this would be the eighths, then you would be at 7/8. And what you would do is get your compass, it's your circle maker, and you would open it up to 7/8. And then you would take your compass from this point. You'd put your pointy part there and your pencil here, and you would mark, make an arc that's 7/8 inches. Now it would be smaller. 7/8 of an inch would be like that. You realize smaller anyway, somewhere in there. Let me try to get a little more accurate. So you'd have a point, and then 7/8 of an inch would be a little arc going across here. I'm still a little inaccurate, but that's okay. You could pick a point, 2 points anywhere on that arc and connect, and that would give you an isosceles triangle, see? And then you connect with the third side, and there you have it. And so you would mark this as 7/8 of an inch and mark this side as 7/8 of an inch. And we would label A, B, C, okay? Scalene obtuse triangle DEF with sides 15 millimeters, 25 millimeters, and 30 millimeters. And what we'll do a lot of times is we'll just start off with a segment. Maybe it's too long, and we'll lay our ruler down and we'll measure where 30 millimeters are on our ruler. And then we'll put that little side there and maybe erase out the rest of it. And then we're going to take our compass and we're going to open it up to 15 millimeters. And we're going to spread our compass out and make an arc from this vertex. And then we'll open up our compass again with a ruler to 25 millimeters. And we'll go from this vertex and we'll make an arc 25 millimeters. And where those two arcs hit, we will connect. And so this would end up being 15 millimeters, 25 millimeters, and 30 millimeters. And remember, the actual width of a millimeter is about the width of a pencil lead. And the width of a centimeter is about the width of your thumbnail. Okay? So when you look at centi, milli, centi actually is going to be about that big. And the millis are the little bitty guys in there that look like the width of a pencil lead. See? Okay? And your teacher can model some of these things for you. I'm not going to try to model every one of these draw and label, but I'm going to show the general idea of how to do it. I would expect my students to do it perfectly, and I would have equipment on a whiteboard or a chalkboard showing them hands-on exactly how to do this. Okay? When it says something like acute triangle JKL, this is number 16. Angle J is 50, angle K is 60, JL is 70, JK is 2 centimeters. And the first thing we would do is measure JK at 2 centimeters. The angle at J is 50, so you would set your protractor there. That's the little semicircle thingy. You would put the hole or the mark here. You would go and find where 50 degrees is, and you would make a little mark. And then you would remove your protractor, and you would draw from here through that little mark at 50 degrees. And then you would set your protractor over here so that the little hole or the little mark or however your protractor design is setting here. And then you got to kind of watch right here because the angle at K is 60, but you may be going backwards from 180 to 120 because that's kind of backwards to 60. And then you would remove your protractor, make the mark, go from here, the vertex, through that mark, and they would hit. And then you put a dot where those meet, and you can erase that stuff up there out of the way if you want, and then you would have your triangle correctly drawn. And you could label all the parts accordingly, okay? At the end of this lesson, we put in some percentage type things, so let's just deal with one of those. Angle A is 18% of the interior angle sum. On page 62 to 63 AA of my Algebra 1 text, it talks about percentages. And there's three basic percentage equations. One is part equal percent times whole. That's basically the algebraic equation definition of percentage. And then you've got new price equal original plus increase, or new price equal original minus decrease, which is how we use percentages in the marketplace of buying and selling. But based on that, if we want to find a part or a percentage of something, we take that percentage as a decimal times the whole thing, and a whole triangle is 180 degrees. So if we take 18% of 180 degrees, it would give us the measure of angle A. And 18 squared is 361. That's wrong. I just forgot what 18 squared was. 324. That was kind of crazy. It left me. 18 squared is 324. So this would be 32.4 degrees. Okay. And you can figure out the rest of that on your own. After that, we have our discovery learning, which again will help us discover the next lesson. And so we want you to use your protractor. We want you to do the measuring. Again, if you're not sure about the conclusion, maybe you didn't measure perfectly, so you can't really see the right conclusion exactly, then go to the next lesson, study ahead a little bit, and you'll find the answers in the theorems in the next lesson. So we're going to try to do some investigating to learn the next lesson.